Now, in number 83, this is a formula. A formula is just an equation that somebody uses a lot, so they call it a formula. Now, in this one, this says that f, whatever f stands for, is equal to r times s divided by v. So to get f, if you knew r and s, you'd multiply those two numbers together, divide that result by v, and that would give you f. But now what we want to do is we want to solve this for r. We want to get r equals something. So let's do that. The process is the same as what we've been using. We have an equation that involves rational expressions, so we get the LCD. So let's draw the LCD. LCD here is just v, and we'll say that v is not equal to 0, right? So we have to exclude 0. There's our LCD. And now, as we always do, we write the LCD right next to each one of the original terms, right? Write it right here and write it right here. So we will get FV equals RS over V times V. Now on the left side, we'll still have the FV, but on the right side, you can see that that V will cancel with that one. Let's do that. That V cancels with that one, and we're just left with this RS times 1, just RS. And we can solve this equation for r just by multiplying by s, right? R is being multiplied by s, so to get r by itself, undo the multiplication by dividing by s. So our plan here is to divide by s. We'll get FV over s is equal to r. And I think I'm going to write it like this. R is equal to FV over s. And as long as s is not 0, we've got the original equation now solved for r. So in problem number 89, what we've got is that s is equal to 2 times b divided by v plus z. And we want to solve it for b. We want to get b on one side, so we want b equals something over here. This is an equation involving rational expressions, so we know what to do. We're going to get the LCD. So the LCD here is just this v plus z, and because there's more than one variable, we're not going to bother with the excluded values. So there's our LCD. And now, of course, we write the LCD right next to the original. So I'll write it here, and I'll write it here. And because there's more than one term, I'm going to use parentheses, right? Parentheses to capture all of it. So it's going to look like this. S times v plus z is equal to 2b over v plus z times that v plus z. Now on the left side, nothing cancels, so I'm just going to keep it as s times v plus z. And on the right side, this v plus z will cancel with that one. Let's indicate that. That one cancels with that one, and we will be left with 2b times 1, or just 2b. And we can solve this for b just by dividing by 2. So our plan now is to divide by 2. So we'll get s times v plus z all over 2 is equal to b. And we can leave it like that. Or if you just like the b on the left side, we could write b equals s times v plus z all over 2. Both of them are good. Now in problem 93, we want to solve this equation for t. Right now it's in this denominator. We want to get t equals something. So let's proceed as we usually do. Let's get the LCD. So the LCD here is that g, the r, and the t. And then as we always do with rational equations, we write the LCD alongside each original. So I'll write it here, here, and here, and then all the denominators should cancel. So let's do that. We get 1 over g times grt equals 1 over r times grt plus 1 over t times grt. Now let's cancel in these denominators. So that g here will go with that one, and we'll be left with that 1 times rt, which gives us rt, equals And now over here, this r will cancel with that one. Let's indicate it. That r goes with that one, and we're left with 1 times gt. Let's write it. 1 times gt is just gt, and then plus, now this t will cancel with that one. Let's indicate it. That one goes to that one, and we're left with this 1 times gr, which gives us gr. Now we're trying to solve this equation for t, right? We want up here. We want to solve it for t. When I look down here, I've got t's on both sides. I've got it here, and I've got it here. So the first thing I think we want to do is get all the t's to one side. Now since I have some over here, let's subtract these. So I think the plan should be this. Let's subtract this gt, right? Subtract that one. So if we do that, it's going to look like this. Our equation will now look like this. RT, now subtract the GT, right? What I've got is RT minus the GT, RT minus GT, equals, now if I subtract equals, and if we subtract GT from this side, it's gone, and we're just left with GR. So over here, we're left with GR. And now, this is pretty common what we're going to see here. I'm trying to solve it for t. T appears in both of these terms. So what we're going to do is we're going to factor it out. So we're going to get t times, now what's left? If you remove that t, what's left is an r minus g. Does that make sense? You got RT minus GT. T is common to both, so take it out, take out the t. And if you do that, what's left? R minus g. And this whole thing is equal to GR. And now we can solve it for t by dividing by r minus g, right? This r minus g is multiplying t, so our plan now is to divide by r minus g. And if we do that on the left side, we divide here, it's gone. And if I divide it over here, we will get t equals gr divided by r minus g, and there we go, we've got it.